Hi there, in this video we are going to go over how to use complex fractions to solve problems involving unit rate. So when you have one or more fractions within a fraction, this is called a complex fraction. Alright, so to simplify a complex fraction, you would just look at them as division problems. Alright, so you would turn it into a division problem and then you would solve it as you would any other dividing fractions problem by keeping the first number, then changing the division to multiplication, and then flipping the last fraction to its reciprocal, or the last number to the reciprocal. All right, so let's see what that looks like here. We have 1/4 divided by 2, or 1/4 over 2. So I'm going to turn this into a division problem, 1/4 divided by 2 over 1. I put this 2 over 1 because when you are just doing 1/4 divided by 2, right, when you do a fraction divided by a whole number, you would need to put a 1 under it before continuing. Right, this way, you can keep the first fraction, you can turn the division to multiplication, and then you can flip the second fraction to be 1/2. And then you multiply across, 1 times 1 is 1, 4 times 2 is 8, then you have 1/8 as your answer. All right, and number 2, we have 1 over 1/2. So really, you would rewrite this as a division problem, 1 divided by 1/2. Well, how do you divide a whole number by a fraction? You would put the whole number over 1 and then change reciprocal. So now we are going to keep the first fraction, change the division to multiplication, and then change 1/2 to be 2 over 1. And now we just multiply across to solve. 1 times 2 is 2, 1 times 1 is 1, and you get 2 as your final answer. All right, let's look at some word problems here. So Josiah can jog 1 3/4 miles in 1/4 hour. Find his average speed in miles per hour. The biggest question I get here is, how do you know what number goes where? All right, so the first thing I want you to do before you start these problems is figure out what your rate is, right? And if you can recall, a rate has 2 different units. All right, in this case, we are working with miles per hour. The per, every time you see per, I want you to think of division. So our rate is miles per hour, miles to hours, okay? Our rate is that ratio with the 2 different rates, miles and hours. Okay, miles goes first, then slash hours. All right, so we have miles over hours. So in this problem, he can jog 1 3/4 miles, right, over 1/4 hours. So let's set this up. This is really 4, 5, 6, 7 over 4, right? Because 4 times 1 is 4, plus 3 gets you 7. So we have 7/4 over 1/4, which really can turn into the division problem, 7/4 divided by 1/4. In order to solve this, you would keep the first fraction, turn the division to multiplication, and flip the second fraction to the reciprocal. So now we have 7 times 4, which is 28, over 4. And now we can simplify this. So 28 divided by 4 actually is 7. And let's not forget our units. It's given right here, 7 miles per hour. Right, again, this was 28 miles and this was 4 hours. All right, so Tia is painting her house. She paints 34.5 square feet in 3/4 hours. At this rate, how many square feet can she paint each hour? All right, so we are given the rate of feet, square feet, in each hour. So our ratio or our rate is square feet to hours. There is no per here, but you're given this each, and that tells you that you need to divide by hours. All right, so we've got here now 34.5 square feet over 3/4 hours, which is really, when you turn this into an improper fraction, 2 times 34 is 68, plus 1 gets you 69 over 2, divided by 3/4. All right, so when you go to rewrite this, you have 69 over 2 divided by 3/4. We are now going to keep, change division to be multiplication, and then flip this to the reciprocal. All right, multiply across. So 69 times 4 gets us 276 over 2 times 3, which is 6. 276 divided by 6 actually comes out to a whole number of 46. And now for your units, we did our units right here, right? It's square feet per hour. Or you can think of it like each, as it's written in the problem. Right? In the problem we were given each hour. All right, and then here's for our last example. Chris mows the lawn every other weekend. He can mow 2/5 of the lawn in 2/3 hours. How long does it take him to mow the whole lawn? All right, so this one's a little bit tricky to try to figure out what's at the top and what's at the bottom. So I want you to think of here where it says the whole lawn. When we're finding unit rate, right, you're trying to figure out what it is for each one, right? So here we figured out how many miles in the one whole hour, okay? In this next problem, we found how many square feet could be painted in one whole hour. In this last problem, we're figuring out how many hours it'll take to mow the whole lawn. So what's going in our denominator is lawns, because we're trying to use one whole lawn. We're trying to figure out what it would be per lawn, for one whole lawn. All right, so then Chris mows the lawn every other weekend. He can mow 2/5 of the lawn in 2/3 hours. So hours to lawn. How long does it take? So that would be the hours. Does it take him to mow the whole lawn, one whole lawn? So we have hours to lawns. All right, now we can set this up. So 2/5 of the lawn, that's going at the bottom. Oops, 2, that should be a 2. All right, and then at the top, we have 2/3 hours. Let's set up our division problem. 2/3 divided by 2/5. All right, we're going to keep the 2/3. We are going to change the division to multiplication, and we are going to flip 2/5 to its reciprocal of 5 over 2. Then we're going to multiply across. So 2 times 5 is 10. 3 times 2 is 6. Then we have 10 over 6, which if you divide both of those by 2, you'll get 5 over 3, or 1 2/3. And actually, let's do our units. So 1 2/3 hours per lawn. All right, thank you so much for watching. Hopefully you learned how to solve problems involving complex fractions and unit rates.